Okay, in this video, we're going to be solving this problem here. This is one that I invented myself and one that I'm very proud of because it contains a lot of stuff. It contains calculus, algebra, trig. At the end, it even contains a bit of critical thinking and number sense. So this is a really mixed problem. And make sure you, when you try to solve it, make sure you don't use a calculator for the entire problem, even at the end. Okay? So pause the video now, try and solve it, and then we'll come back and do it together. Alright, assuming you've done that, and you've paused, you've solved it, and you're ready to check your answer, let's go. Okay, so the problem says that f of x equals a definite integral from 0 to 2a cubed of sine of x over a dx, where a is a real positive constant less than 3. How many values of a are there such that the quantity f of x times the quantity f of x minus 4 whole squared equals 10 times f of x minus 4 f of x squared? No calculator, of course. Okay, so how are we going to do this? Let's see. First thing I'm going to do is I'm going to deal with this part here, okay? You can either deal with this algebra part, or you can deal with this calculus part. You can do them in whichever order you want. I'm going to do the algebra one first, okay? So the first thing I'm going to do is, instead of saying f of x over and over, because the parentheses are going to get really confusing, for me at least, I'm going to say that f equals f of x, where f is just a function of x, right? So I can just replace f here instead of f of x to get rid of some of these annoying parentheses. So we'll have f times f minus 4 squared equals 10f minus 4f squared. Look at that. Okay, now we can expand this. I'll get f times f squared minus 8f plus 16 equals 10f minus 4f squared. Next thing I'll do, I'll take this entire thing and bring it over here. So that'll be f times f squared minus 8f plus 16 minus 10f plus 4f squared. Remember, when you bring it over, you switch the sign, right? Okay, and this is equal to 0, of course. Okay, now what we can do is, there's an f here, there's an f here, there's an f here. We can take them all out and we'll bring one f on the end. And then in the middle, we'll have f squared minus 8f plus 16 from before, and then minus 10, and plus 4f is equal to 0, okay? I can simplify this interior part. I'll get f times f squared. Let's see, we have a minus 8f and a plus 4f. It's going to be minus 4f. And then we also have a plus 16 and a minus 10. That's going to give us a plus 6. It's equal to 0, okay? So if we want this equation to be true, we have one of two options. Either f equals 0, or this equation f squared minus 4f plus 6 equals 0. Or technically both, but that's not really an issue here, it seems. Okay, so how do we get this equation? So either f is 0 or this is 0, right? This is obvious enough, it just yields the solution f is equal to 0. But this quadratic equation here, we're going to have to solve it to get the values of f such that this is equal to 0. So how do we solve this? Well, you can try doing normal factoring, but that's not going to work out. So we have to rely on our old friend, the quadratic formula, or, completing the square if that's your thing. Okay, so remember, quadratic formula, we have a is the constant here, b is the constant here, c is the constant here, 1, negative 4, 6. We'll plug that into our quadratic formula equation that we remember from the song. Right, everyone's singing in their heads right now, I'm sure. Negative b, so it's going to be positive 4, plus or minus square root of b squared, so it's going to be negative 4 squared, which is 16, minus 4 times a, which is 1, and then c, which is 6, all over 2a, which is over 2, okay? I can simplify this part. 4 times 1 times 6 is 24. 16 minus 24 is negative 8. This is 4 plus or minus the square root of negative 8 over 2. Now, square root of negative 8, this is going to yield us no real solutions, right? So that means we can just take this entire section here and just kind of ignore it, because it's not going to yield us any real solutions for f. So that means the only solution we have left over is this f equals 0 here. Okay, so if we go back up here, we want to know how many values of a are there such that blah, 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 blah. Well, if we want blah, blah, blah to be true, this just basically means f of x equals 0. Right? That's the only solution for this equation. So we want to know how many values of a are there such that f of x equals 0. Okay, cool. Now we'll move on to the calculus section. We'll scroll down a bit, and I'll rewrite the integral. Let me just look it up. Okay. So it is the definite integral from 0 to 2a cubed of sine of x over a dx. Okay? Now let's see. The actual integration here is not very difficult. We'll simply do u substitution, where u is going to be equal to x over a, which would mean that du is equal to 1 over a dx. I'll draw the arrows here. Or a du equals dx. Plugging that back in here, we get a times the integral from x equals 0 to x equals 2a cubed of sine of u du. Notice I'm saying x equals 0 and x equals 2a cubed because I don't want to confuse myself and then say that these are the bounds for u. These are actually the bounds for x. Okay, so if I evaluate this and switch u back to x over a, this gets me negative a cosine x over a, evaluated from 0 to 2a cubed. Plugging in the bounds, I get negative a times cosine of 2a cubed over a, plus, because the negative and the other negative make a positive, a cosine of 0, because 0 over a is 0. Okay, if we can simplify this, we can, first of all, since at the very beginning of the problem, we said a is a real positive constant less than 3, right? That means a is greater than 0. So if we cancel an a here and an a here, we're not going to be dividing by 0, so we're good. That means we'll have negative a cosine of 2a squared plus a. Cosine of 0 is just 1, so this is just a. Okay, I'll finally factor an a out. I'll get a times 1 minus cosine of 2a squared. And now remember, this is f of x, right? F of x is a definite integral, so we got this constant value here. We want f of x to be equal to 0, right? What if I get how many values of a are this so f of x is equal to 0? So what we'll do now is we'll take our equation for f of x and we'll set it equal to 0. So a times 1 minus cosine of 2a squared equals 0. Now this is going to yield us two options, similar to how we did this with the quadratic before. So either a equals 0 or 1 minus cosine of 2a squared is equal to 0. But remember, from the very beginning, we said that a is a positive constant less than 3. So a is positive, it's greater than 0, and it's less than 3. Okay, a is a positive constant less than 3, and it's a real constant. Okay, so what does that mean in our equation here? Well, it means that a cannot be 0, because we said that a is greater than 0 and less than 3. So that means the only solution we have left over is that 1 minus cosine of 2a squared is equal to 0. So if I take this equation and I add cosine 2a squared to both sides and I flip it around, I'll get cosine of 2a squared equals 1. Okay, now I have to think about what values of a can I plug in such that cosine of 2a squared equals 1. We'll have to think about now, okay, cosine of what equals 1? Well, the answer to that is cosine of 2 pi n equals 1, where n is an integer. Okay, so I can think about what values of n can I plug in here to make this equal 1. Well, I can plug in any integer value. Okay, so since cosine of 2a squared is equal to 1 and cosine of 2 pi n is equal to 1, I can set these equal to each other and say 2a squared equals 2 pi n. Canceling the 2's and simplifying gets me a is equal to plus or minus the square root of pi n. Okay, but remember, write it again here, a is a positive number less than 3. So we can ignore this plus or minus and just say it's just a plus, because there's not going to be any negative values of a. Let me just put this a bit closer. There we go. Okay, so a is equal to the square root of pi n. Okay, Let's think about what values of n I can actually plug into here. If I plug in n is less than 0, then I'll get square root of pi times a negative number. So we'll get a negative inside of the square root, and that's going to mean that a is not a real number. Remember at the beginning we said a is a real number, so you can't plug in any negative values of n. Okay, what about n equals 0? Well, if you plug in n equals 0 here, then you'll get a is equal to 0. But we said a is greater than 0, so n can't equal 0 either. So what that means is that n must be greater than 0. Okay, so now what we'll do is we'll plug in different positive values of n. And remember, n is an integer, right? It's not a decimal or anything. So we'll plug in integer values of n into here and see what a is equal to. All right, so let's try n equals 1. If n equals 1, then a is equal to the square root of pi times 1. And then, let's see, so is this less than 3? Okay, well, let's think about this, okay? 3 is 9 squared, right? So the square root of pi the question is square root of pi less than 3? And 3 is the square root of 9. So I can say, is the square root of pi less than the square root of 9? Well, let's see, so pi is definitely less than 9. So that means the square root of pi is less than square root of 9. So that means the square root of pi is less than 3. So that means a is equal to square root of pi is a valid solution. Okay, now let's try n equals 2. That's going to mean a is equal to the square root of 2 pi. And the question is this less than the square root of 9? Well, let's see. Pi is a little bit greater than 3, right? So 2 pi would be like 6.28 something. And that's definitely less than 9. So that means since the square root of 2 pi, since 2 pi is less than 9, then the square root of 2 pi is less than the square root of 9. So the square root of 2 pi is less than 3, so n equals 2 is a solution. So I'll put a green check mark next to both of these. Okay, now let's try n equals 3. That's going to mean a is equal to the square root of 3 pi. And the question is this less than the square root of 9? Well, let's see here. 3 pi and 9, pi is a little bit greater than 3, so 3 pi is going to be 9 point something. Well, that's actually going to be greater than 9, right? So since 3 pi is greater than 9, the square root of 3 pi is going to be greater than the square root of 9. So that means this is actually not going to be a valid solution. Since if I plug in n equal 3, the value that we get for a is greater than what's indicated in our bounds here. So that means we only have these two valid solutions. So we have two solutions. We have a equals square root of pi and a equals square root of 2 pi. And if you look up at the beginning, the question asked us, how many values of a are there such that this is true? And then we answered it down here. We said, oh, there are two solutions such that that is true. So what this means is a equals square root of pi and a equals square root of 2 pi. If you took those two values and plugged them into here and here, this integral would evaluate to 0. Those two values are the only two values that are positive and less than 3 that will make these that will fit that criteria. Okay, so I hope you found that problem interesting, maybe a little bit challenging, but hopefully not too much, and I hope you learned something from it. Yeah, I'll see you next time. Goodbye.